So welcome back. This is part two in our series where we're talking about a very important engineering and software development concept used in the real world in many places, and that is the concept of state machines. And state machines are basically a way to control real world equipment. And previously we did videos talking about other ways to control real world electrical equipment. We talked about feedback control systems. We talked about the basics of those and how they work. This is yet another way to control real-world electrical equipment. And to understand state machines, we are using this very simple example that you see here that you're probably familiar with, and that is the control system to control traffic lights at an intersection. And I encourage you to look at part one where we talk about the basics of this and what we need to think about. In this video, we're going to take what we learned so far and try to implement a very simple algorithm that we can put into our simple software code. Doesn't matter what language you use, the concepts are what's important here. We're going to use C# and we're going to make a very simple application that will simulate this traffic control system. And by doing so, we're going to learn about state machines, and we're going to learn about some very important things you need to be aware of when implementing state machines or anything else to control real-world equipment. You can't just copy and paste code. You need to understand it, because if you get your traffic lights wrong, you can have traffic accidents. So we're going to talk about some of those very important concepts. So in the previous video, we talked about a very simple intersection with 4 traffic lights. And we said that these traffic lights can be viewed as being in one of 4 different states at any one time. So for example, state 1 we can say is where the horizontal traffic going left and right has a green light, while the vertical traffic has red lights and the traffic can't go. So that's state 1, and generally you can imagine that it stays that way for maybe 60 seconds to allow the horizontal traffic to go. And then state 2 is where the horizontal traffic gets a yellow light to say, hey, slow down, the light's going to change. And it's that way for maybe 5 seconds. And then state 3 is where the vertical traffic has a green light. The horizontal traffic gets a red light, and that means they have to stop. And then state 4 is where the vertical traffic gets a yellow light saying, hey, the lights are going to change. You're going to get a red light. And then we go back to state 1 where the vertical traffic gets a red light and the horizontal traffic gets a green light. And we talked about a basic conceptual diagram of what our state machine controller is going to do. It's basically going to set up those 4 states and how to turn on and off those different traffic lights. And we said in the real world, it might not be 4 sets of lights, it might be many more, but we're going to start out with a very basic concept. And we also talked about how there might be input information that will affect the logic. So for example, if there's occupation sensors that say, hey, there's no traffic on these vertical roads, so we don't need to change the lights. We can just let the horizontal traffic run until we get some vertical traffic. And basically our state machine controller is going to make sure that we're in the correct states for the correct amount of time, taking into account any external information like occupation sensors. So let's take a look at this basic core application, how we can set up a algorithm, some simple logic to do this. For now, we're going to forget the external occupation sensor or any other information. We're just going to see how we can set up the lights to go 60 seconds in one state, and then 5 seconds in another state, and then another 60 seconds in the third state, and so on. So if you think about it, the basic task for our software controller is we want to be in state 1. We can say that that's the horizontal traffic has a green light for 60 seconds. Then we're going to go into state 2 for 5 seconds where the horizontal traffic suddenly gets a yellow light, says, hey, you got to slow down. And then state 3 where the vertical traffic has a green light. And then state 4 where they get a yellow signal. And then it goes back to state 1 where the horizontal traffic can go. So if you think about it, this is a very simple control system, right? In state 1, you do something for 60 seconds, you set up the lights. State 2, you set them up for 5 seconds, and so on. So you can imagine state 1, for 60 seconds, we make sure that light number 1 is red, light 2 is green, light 3 is red, and 4 is green. And that gives the horizontal traffic a green light. And then we have to make sure that for 5 seconds, those green lights for light number 2 and light number 4 turn to yellow, but the others maintain red. And then state 3, where the vertical traffic can go, the reds turn to green, the yellow turn to red, and so on. So really, every state, all we have to do is set those lights to a specific color. Now, in the real world, what that's going to be doing is going to be sending a signal to turn on real-world electrical lights that might draw many amps, especially if you have a lot of lights. So you might be sending a signal to operate a relay, an electromechanical relay, or a MOSFET or something to turn on and off those lights. So you might need a high-powered device to actually turn on and off the lights. But for now, we're just going to assume we just need a logic signal to turn these on and off to the correct colors. But basically, we can do some logic to turn on and off these lights. And once we've got that, we're going to do something that's very, very important. We're going to make sure, in our case, if we get the lights are wrong, we could get traffic accidents. So part of this, since we're operating in the real world, these things have to be verified and double-checked and triple-checked to make sure we don't have any errors in our lights. And what we're going to do in this video is we're going to start to develop in C# this simple application where I hit the start button, and you can see we've got 4 lights for the vertical traffic and for the horizontal traffic. Right now the horizontal traffic has green light, and these are going to turn to yellow. They turn to yellow, so the horizontal traffic slows down. Those go to red, and then the vertical traffic gets a green light, so they're going to go. And then, as you can imagine, that's going to be for a while. Then they're going to turn yellow, and that traffic's going to slow down. It's going to go to red, and then we're going to get green lights. So that's the goal, the basic algorithm, the state machine, where it's putting it in 4 states and just looping and continually going through those 4 states. And here is our basic C# Visual Studio Windows Forms application. And I've got a basic form here, and I've got some picture boxes that I'm going to put those images of the different lights. And I've got a start button and a stop button. Very, very simple. And here I've got some code that basically all it is I've got a couple of button click event handlers for the start button, for the stop button. And then I've got a method that runs the simulation. And what happens is when I hit the start button, I set a Boolean run equals true, and then I call this run sim method. And that loops through continuously and does the simulation. So I've got this Boolean, I start out with run equals false, and I've got a path for the images. But basically, it's going to, when I hit the start button, I'm just going to run this run sim method. And all it's doing, a continual loop, while this run Boolean is true, and I can set it false in the stop button. But for our purposes, it's just going to run continuously. And each time it goes through this while loop, it's going to set the 4 states sequentially. And what it does is it basically calls this method, setState, and feeds it the state number as an integer. And this method is going to set all the lights, and it's going to have the internal delays to make sure that everything is set up correctly and it stays red or green for 60 seconds or however long, and the yellow lights are there for 5 seconds and so on. But basically very simple. Set state 1, set state 2 where the greens turn to yellow, set state 3 where the other traffic goes, and then set state 4 where they get a yellow, and then it goes back to state 1. Right? So very, very simple application. And here is our set state method, and all I'm doing is I'm using a switch case statement. And it's taking that state number, and if it's state number 1, what it's doing is it's setting the image in the picture boxes to red for 2 of them, and then green for the other 2. And you can see what I've done is I've started out with the reds first because I want to make sure that the red lights get turned on before I worry about the green lights, right? So that's really important. You got to make sure, again, this is a safety thing. You're talking about real world traffic signals. So you want to make sure that the red lights get turned on, then the green lights, okay? Now I've got a commented out thing that we're going to see a little bit later comes in to play. But after we've set the red and green lights for state 1 or case 1, we're going to have a task.delay.wait that waits, in our case, 6 seconds. In fact, it should be about 60, but for the purpose of this demonstration, I'm going to keep it short at 6 seconds. So the horizontal traffic is going to have a green light and the vertical traffic is going to have a red light for 6 seconds, and then it's going to break. And then it's going to go to the next one, state 2. And it's going to go down to here where it's going to set the red lights. It's going to keep them red, and it's going to set the greens to yellows. And it's only going to wait 5 seconds, which is typical for a yellow light. And then it's going to break, and then go back to the next one, state 3, and so on. So really, it's just a switch case statement with built-in delays, and it should help us to set those lights the way we want them. Now, keep in mind, as we're going to see here in a moment, this is certainly not an ideal way to design this, but at least it gives us a conceptual structure that we can then modify to make it ideal. So let's run this, and I'm going to hit start, and you can see it populates them, and then these should be turning to yellow. And you can see they do, and then these turn to green, and these should turn to yellow, they do, and then they should turn to red, and these should turn to green, and they do. But you can notice that not always is the timing correct. And see, they do it sequentially instead of simultaneously, and then they should turn green. And see, the timing doesn't really allow much time between these different states. So we have to be very careful when we're writing our code. We have to be aware of how we need to make this so we do have specific delays and everything is working correctly. So this is not ideal, but it's a basic structure. So let's see how we can modify this to make it a little bit better. So what I've done is I have added a delay of 1 second after I've set up the reds in each of these. I've got a task.delay, and I'm going to uncomment those, and the same here, and the same here, and the same here, and that should make it a lot nicer where you've got a fixed delay after we set up the reds to make sure that the reds are set before we do anything else. So we're going to start, the reds are set, then we have the greens. These should go yellow simultaneously. They go yellow, and we can notice those are red, and then this turns green. So it's really important that you fine-tune this and verify. Again, this is a safety issue. Make sure that you've got everything set and the timing set. And then those are all red, and then these go green. So it's really important in this particular state machine that you make sure you've got your states configured and you've got your timing correct. Now again, this is kind of a brute force method. This isn't how you do it in the real world. Part of this is because in the Visual Studio C# Windows Forms application, the response of these picture boxes is kind of slow, but that's what you deal with in the real world. You're going to have some time delays for real world equipment and relays to operate, and you have to take all that into consideration. So at this point, we have a basic structure for a very simple application that controls our lights. However, we're going to need to modify this to include, for example, external information like the occupation detection sensor information that will tell us, hey, we need to have some more states and different delays. So we're going to have to add that. And we're also going to want to think about how we can optimize this to make it work a little bit better and more efficiently. So that's it for this one. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.